AI is hitting a wall, not a metaphorical wall, a physical one, made of data, energy, and the hard limits of classical computing. And while everyone is watching the AI race, something else is quietly being built in labs around the world. Something that doesn't just run faster than what we have. Something that works in a completely different way. In October 2025, Google published a result that most tech channels completely ignored. A quantum chip solved a molecular simulation problem, 13,000 times faster than one of the world's most powerful supercomputers. Not a synthetic benchmark, a real scientific calculation, independently verified, the kind of milestone researchers spend entire careers working toward. Nobody talked about it. Everyone was busy watching the AI race. And that might be exactly what the people building quantum computers are counting on. In today's breakdown, you're going to understand what quantum computing actually is, why it can do things AI never will, and why the world's most powerful governments are pouring billions into a technology most people still think is science fiction. By the end, you'll see that this isn't a story about quantum replacing AI. It's a story about what AI actually needs to survive. There's also a threat already unfolding right now, one that governments and tech companies are quietly racing to stop, before most people even realize it exists. Let's get into it. The ceiling. Here's something the AI industry doesn't like to say out loud. The formula that built ChatGPT, Gemini, and every other major AI system is running out of road. For a decade, the approach was simple. More data, bigger models, more computing power. It worked almost too well. Every time researchers scaled up any part of that equation, the systems got dramatically smarter. They called these scaling laws, and for a while, they felt almost like laws of physics. If you watched our previous video on why the AI software era is ending, you already know how deep that crack runs. Ilya Sutskever understood those laws better than almost anyone. He is the co-founder of OpenAI. He helped build GPT-3 and GPT-4. In late 2025, he said something that stopped a lot of people in the industry cold. Pre-training as we know it will end. We have but one internet. The age of scaling is over. The person who helped build the AI era is now saying the era is closing. Part of what he means is data. AI models have essentially consumed the entire written internet. Every article, every book, every forum thread that was ever digitized. That resource is not infinite, and making models bigger on the same data produces smaller and smaller returns each time. But there's a second wall, and this one is physical. The International Energy Agency projects that data center electricity consumption will more than double by 2030, reaching around 945 terawatt hours per year, nearly 3% of all global electricity. AI is the main driver. Some projections suggest a single large training run could demand as much power as 8 nuclear reactors by the end of this decade. You cannot keep building more capable AI if you cannot power it. That is not a software problem. That is a physics problem. And physics problems require a completely different kind of answer. A different kind of machine. Here's where most explanations of quantum computing lose people. So let's do this carefully. A classical computer, the kind running every AI system in existence, works by processing information as a sequence of ones and zeros. It is extraordinarily fast at this, but it is still fundamentally sequential. It checks possibilities one at a time, even when doing it billions of times per second. Think of it like navigating a maze. A classical computer tries one path, hits a wall, backs up, tries another. It gets to the exit eventually, but it checks every wrong turn along the way. A quantum computer works differently because of a property called superposition. A quantum bit, called a qubit, can exist in multiple states simultaneously. It is not checking one path at a time. It explores many paths at once. And through a process called measurement, it arrives at the answer. That sounds abstract, so here's what it looks like in practice. In December 2024, Google's Willow chip completed a benchmark calculation in under 5 minutes. The same calculation would have taken one of today's fastest supercomputers 10 septillion years. That is a 10 followed by 24 zeros. To put that in perspective, the universe itself is only about 14 billion years old. Now, that specific benchmark was designed for quantum computers and has no direct real-world application. Google's own researchers say so openly. But what happened 10 months later is a different story. In October 2025, Google ran a quantum algorithm on a problem that actually matters, simulating the structure of molecules relevant to drug discovery, 13,000 times faster than the best classical supercomputer. Published in Nature, reproducible, verified. That is the moment the era of quantum advantage quietly began. The problem's too big for AI. So why does any of this matter for AI specifically? Because the problems quantum solves are exactly the problems where AI hits a wall. Take drug discovery. Developing a new drug takes an average of 10 to 15 years and costs billions of dollars. The bottleneck is molecular simulation. There are a near infinite number of ways atoms can bond and interact. Classical computers have to simplify these calculations to make them manageable. They approximate. They guess. Quantum computers simulate quantum systems natively because they are quantum systems. They do not need to approximate. McKinsey estimates quantum computing could unlock between $200 and $500 billion in value in life sciences alone by 2035. Airbus is running quantum optimization experiments on cargo loading. An aircraft's fuel efficiency depends on precise weight distribution across thousands of variables simultaneously. A small miscalculation burns thousands of extra kilos of fuel per flight. Classical optimization finds a good answer. Quantum finds the best one. JP Morgan Chase is exploring quantum algorithms for financial risk modeling. The problem is calculating how thousands of market variables interact with each other at the same time. Quantum handles this natively. Banks that solve this first will see patterns in market data that their competitors literally cannot access. What all of these have in common is this. They are not problems where you need to search faster. They are problems where the number of possible combinations is so large that classical computers can only ever explore a fraction of the total space. Quantum does not just accelerate the search. It changes what can be searched at all. This is why Nvidia, the company that built the hardware backbone of the entire AI industry, quietly began investing in quantum firms in 2025 and built a platform called CUDA-Q, specifically to make quantum and classical computing work side by side. And it's why Jensen Huang, who said in January 2025 that useful quantum computers were 15 to 20 years away, stood on a stage just 6 months later and said, "Quantum has reached an inflection point." The threat no one is talking about. Here is the part that should make you uncomfortable. Every message you have ever sent, every bank transaction, every medical record, every government communication, all of it is protected by encryption, specifically by the mathematical difficulty of factoring enormous numbers. Classical computers cannot crack this in any useful amount of time. It would take longer than the age of the universe. Quantum computers can crack it. Running an algorithm called Shor's algorithm, a sufficiently powerful quantum machine, could break the encryption protecting most of the internet. This moment has a name, Q-Day, and most experts place it somewhere in the early to mid-2030s. But here's what makes this urgent right now, years before any quantum computer is powerful enough to do it. Intelligence agencies have been warning for years about a strategy that sounds almost too patient to be real. Collect encrypted data today, store it, wait for Q-Day, then decrypt everything at once. It has a name. Harvest now, decrypt later. And it doesn't require a quantum computer today. It just requires one eventually. American intelligence services flagged this publicly in 2021. Researchers estimated in 2025 that the quantum power needed to crack standard internet encryption is closer than previously thought, and the timeline is compressing faster than most people expected. The data being harvested right now cannot be re-encrypted retroactively. Whatever has already been collected is already gone. The world is not sitting still. In August 2024, the U.S. National Institute of Standards and Technology finalized its first 3 post-quantum encryption standards, new mathematical frameworks designed to resist quantum attacks. Apple deployed post-quantum encryption in iMessage in early 2024. Signal added it in 2023. The backbone of the internet is quietly being rebuilt around a threat that hasn't fully arrived yet. That is how seriously the people closest to this are taking it. The race underneath everything. If you want to understand the true scale of what is happening, look at how governments are behaving. Because governments do not spend billions on science projects. They spend billions on strategic advantages. In 2025, the United States committed over $2 billion to quantum firms under the CHIPS Act. IBM alone received $1 billion. The U.S.-China Economic and Security Review Commission called for a national quantum-first goal by 2030. The U.S. banned most American investment in China's quantum sector, effective January 2025, and imposed export controls on quantum technology. China has invested an estimated $15 billion in quantum research, backed by direct state support, treating it as a geopolitical priority alongside AI and semiconductors. This is not enthusiasm. This is arms race behavior. McKinsey's Quantum Technology Monitor projects the global quantum technology market could reach up to $97 billion by 2035 and approach $200 billion by 2040. The first quantum company to cross $100 million in annual revenue did so in 2025. That company is IonQ, reporting $130 million for the full year, a 202% increase over the year before. These are still small numbers compared to the AI market, but they follow a pattern that should feel familiar. In 2019, AI revenue was a rounding error in most company reports. 3 years later, it was reshaping entire industries. The next chapter. So step back for a moment. Remember what the intro said, that the people building quantum might be counting on everyone staying distracted by AI. Here's why that's true. Every month, the mainstream conversation stays locked on AI models and chatbots. Quantum researchers get more time, more funding, and less scrutiny to build the infrastructure that will matter most when the two technologies finally converge. The quiet ones are often the ones moving fastest. What is the honest picture? Quantum computing is not replacing AI. That framing misses the point entirely. AI is a pattern recognition engine. It finds structure in data that already exists. Quantum is a simulation engine. It models realities that have never existed, tests molecules that have never been synthesized, solves problems that classical hardware cannot even properly define. The realistic near-term picture is hybrid. Quantum processors working alongside classical AI, each doing what the other cannot. IBM's roadmap targets a fault-tolerant quantum system by 2029. Nvidia is building the infrastructure to connect both worlds. The convergence is not coming someday. It is being engineered right now. But let's be honest about the gap between where we are and where the hype says we should be. Current quantum machines are fragile, error-prone, and operate at temperatures colder than outer space. The milestones are real. The timelines are uncertain. And anyone promising you a specific date for quantum dominance is probably selling something. What is not uncertain is the direction. A verified quantum advantage, 3 finalized post-quantum encryption standards, billions in government investment, a geopolitical race accelerating on both sides of the Pacific. AI opened a door. Quantum may be what's on the other side. The transition will be slow, then sudden. It always is. If this gave you a clearer picture of where things are actually heading, hit the like button and subscribe. It genuinely helps this channel keep going. And drop a comment. Do you think quantum will deliver on its promise this decade? Or is the hype still running too far ahead of the reality? That's the breakdown. See you in the next one.